Hi, welcome to this edition of Tech Thursday. I'm Mark Evans. I'm the UK&I Chief Security Architect for our DXC security consulting business. I've got over 20 years experience in the industry, and I'm very much a security technologist interested in where security tech is going to take us and help us go. So today we're talking about driving enterprise cyber resilience. And I'd like to introduce the rest of the team. So Faisal, if you could introduce yourself, please.
Hey, it's Faisal Siddiqui. I'm Chief Technologist for Innovation at DXC. And today I'm really interested in talking about security implications around blockchain technology and particularly digital identity and self-sovereign identity.
And Jerry?
Hi, I'm Jerry Overton. I'm a data scientist and a DXC fellow. I'll be talking about how artificial intelligence affects cybersecurity.
And Martin?
Hi, I'm Martin Riley. I work within our digital identity team, and I'm interested in all things to do with digital identity.
Okay, and to begin, I suppose we should introduce the subject. So cyber resilience, what do we mean and what is it? NIST in the States defines cyber resilience as the ability to anticipate, withstand, recover from, and adapt to adverse conditions, stresses, attacks, and compromises on systems, which is a mouthful and probably far too complex in its definition. Cyber resilience is really about corporations, enterprises dealing with the complexity of the modern world, and particularly dealing with the complexities of moving into the digital world. The World Economic Forum recognizes the fact that cyber resilience is a key enabler and a key driver that enterprises need to keep in place and keep their resilience and their cyber hygiene strong. We're really talking about the ability for enterprises to not only protect their critical assets, which in a digital world is predominantly their data assets, but also to be able to detect and anticipate attacks, accept the fact that they're probably not going to be able to stop attacks, but have the ability to recover as rapidly and effectively from them as possible, then adapt going forward to try and mitigate the potential of those attacks occurring again. Cyber maturity is a critical aspect of that. So enterprises really need to keep a handle on what their cyber maturity state is and how they can maintain and increase that with continuous and ongoing security improvement programs. Cyber resilience is really something that has to have board level visibility down. Cyber risk was again recognized by the World Economic Forum as something that requires strong governance from the top level of an enterprise down. So it takes quite a lot of effort to be cyber resilient, particularly in the modern digital world, with organizations going through digital transformations, having to adapt and change to the requirements of their customers and clients as they move forward to maintain their position in the market space. Having a strong backbone, like a strong cyber reference architecture in place, is certainly an aid and a reason that DXC maintains and uses a cyber reference architecture as a backbone for its security consulting and its security business as a whole, but also across the breadth of its offerings and capabilities as itself an enterprise servicing its customers and its customer organizations. Most enterprises today are somewhere on that journey to cyber resilience. Many are still in the world that we're hoping to move away from, of looking at their corporate boundary, their enterprise perimeter, as a finely defined, clear point that they can control and protect. But this is no longer the case with the move to the cloud, with the increased commoditization through all the way to the endpoint. Then enterprises really no longer have a defined, clear enterprise boundary. I mean, we've issued papers recently talking about thriving in a digital world and identity within that space. And Martin, I mean, one thing that we brought out in that was really the criticality of identity to help form that boundary. Perhaps you could mention that moment.
Yes, Mark. For me, digital identity is often the core, because in any kind of digital transformation, your citizen or your customer is really the heart of your business. So the thing that you have for each citizen or customer is their digital identity, and you need infrastructure around those digital identities that's resilient. You know, organizations sometimes used to have a server under a desk in a porter cabin, and that was the route that all the access through their organization ran, and it was neither resilient nor robust. It was fragile and ready to fall over. And now we've kind of moved people into a world where we host identity as a service in the cloud. So we give them that scale and elastic flexibility you can only get from the cloud. And we give a point of sort of central focus for applying policy and able to bring on board other technologies like AI and machine learning to make sure that every interaction across that boundary, every sort of touch of identity, every authentication, we're looking for patterns that indicate threat actors or dangerous behaviors and intelligently pick those out. So I think for me, digital identity is that kind of core wrap for protecting our data, no matter where it is, but with intelligence for doing that.
Okay, and I mean, one theme that you brought out there was AI as an aspect. Situation awareness across an enterprise is now far more complex environment to understand where their information, their data is being used, controlled, processed, consumed is key. And I suppose that's one area where AI could certainly be in the future of improvements. I mean, Jerry, is that something that you could perhaps expand upon?
Yeah, well, actually, there's a couple threads that I want to tug on. So, Martin, you were talking about identity, and there's some really interesting things that are happening between identity and artificial intelligence that bring about some pretty interesting scenarios around security. So when I talk about artificial intelligence, I'm talking about an algorithm. It's usually built on machine learning algorithms where you feed in data, the algorithm learns, and it learns to simulate human level intelligence in some really specific area. Now, given that you have programs out there like that, there's an interesting trend that's happening with identity. So the identity is more than just metadata. So I'm more than just my age, my social security number, my current location. There's a digital footprint that I leave. Mm-hmm. These types of activities or the blog posts that I write. Those things are part of my identity. They're part of a public record. And with the machine learning algorithms that we have now, those things can be emulated. You can actually write an algorithm to do like a virtual Faisal. And the thing is, if we know that Faisal communicates quite a bit with Mark, we can create our virtual Faisal and use that as the basis for a phishing attack against Mark. And so in this way, the changing, dynamics of identity plus artificial intelligence, it starts to evolve this new cybersecurity threat that we have to deal with.
Okay, and so you're really talking about AI potentially being an aid to the threat actor, so itself becoming a source of threat. But what about AI in the context of cyber resilience, cyber defense, helping us understand that situation awareness across the piece, matching things like threat actors together with behaviors that potentially we can detect?
Yeah, so that's the second aspect. So there are three basic things that I'd like to talk about here. The first was, identity management overlapping with cybersecurity, overlapping with artificial intelligence. The second, and thanks for the plug here, is I'd like to talk about artificial intelligence as a tool. It's emerging as a tool to be able to improve security. And one of the ways it's pretty much mainstream now that you can use artificial intelligence. And remember, we're talking about algorithms that look at data, pull out patterns, and use those patterns as ways to learn and emulate human behavior. You can use artificially intelligent algorithms to look at patterns of usage of your infrastructure. Now, the reason that that's valuable in cybersecurity is that you can have an algorithm pick out abnormal usage in your infrastructure. So if you see something that's weird, if you see usage that's out of the ordinary, that's a red flag. You can put a human being in that loop. You can raise the red flag out to a person and have them look at that abnormal usage and figure out whether or not that's a false positive or whether or not that's an actual security risk that you need to look into. And there are a number of firms that have decreased the time it takes to respond to a security threat, and they've increased their resilience by deploying these types of smart anomaly detecting algorithms to help them with their security resilience. Now, these algorithms themselves then introduce other security holes, which I hope to get to talk to about in just a little bit. But that's one of the areas where artificial intelligence is useful as a tool to aid people who are trying to increase the resilience of their organization.
Okay, and you mentioned that it can potentially bring in additional security holes as well. So what really are you talking about as security holes in this context?
Well, let's see. There are a number of them. The first is, well, I talked about using an algorithm to detect anomalies. Well, you can also use algorithms to understand other algorithms. Now, that might sound a little science fiction-y, but that's actually a pretty common practice in data science, where when you build an algorithm and you want to understand its future behavior, you want to create a profile of that algorithm, you create a second machine learning algorithm to tell you about the first one. Well, if you create an algorithm that's capable of detecting anomalous behavior, things like anomalous use of your digital infrastructure, it's possible, in fact, it's going on now, that cybersecurity attackers create second algorithms to profile those first ones, figure out how you are detecting anomalous behavior, and get better at hiding attacks. So you can actually write an algorithm that will get you, that will make you more effective at launching an attack, but keeping it under the radar of the algorithms that were designed to detect those attacks.
Okay. I mean, it's an interesting subject area, and it's certainly growing. And I've been challenged on a number of occasions with are threat actors using AI? I think the answer is yes.
Of course.
And it's kind of like this arms race, right? You put in an algorithm to stop it, someone else puts an algorithm to detect that algorithm's behavior, and on it goes.
And I suppose the other aspect is that they're using machine learning as part of their intelligence effort as well to perform the reconnaissance work that they're doing on us as enterprises to launch those phishing attacks, to find those weaknesses and those weak points. I suppose the other area that perhaps we need to discuss is data and data security. So data is a critical aspect of the digital enterprise, but the data in itself is now in transit across all sorts of untrusted environments and networks to the point at which we really need to understand what information we're consuming, what information we're controlling, and where it is and where it flows, so that we can best secure it. But one thing, Jerry, that you brought up that you perhaps wanted to cover was data security, and really a layered approach to data security. Is something you can expand on?
Yeah, and this is an interesting aspect, and this ties into blockchain. So I want to pass it over to Faisal as well, in that when you have an algorithm and that algorithm learns over time, then its future behavior really depends on the data that you're feeding it. So you have to make sure that that data has a certain level of integrity, or your algorithm could actually learn to become a security threat. Now, one of the things that you do is you have to monitor the algorithm constantly to see what it's learning and the behaviors that are emerging, but you also need to check the data source to make sure that it hasn't been tampered with. And from what I understand, there's pretty interesting applications of blockchain that allow you to do that, but I'm not an expert in that. So I wanted to ask you, Faisal, what have you seen in that area?
First, Jerry, I love the idea about the algorithm, colliding with the other algorithm. It really reminds me of the idea of the Terminator being reprogrammed as he comes to kill Sarah Connor.
Yeah, and it sounds very science fiction-y, but again, these are practices that happen now.
And they're happening today. And that's such a perfect segue into the blockchain conversation, because really, fundamentally, what we're doing with this idea of blockchains isn't so much as some kind of distributed database technology, but we're solving this problem of where natural intelligence, or what I sometimes think of as artificial intelligence, falling short, right? Because what we're really doing is we're putting this human being in the middle of this. In fact, Gary, you mentioned this. We put human beings in the responsibility of securing networks based on their own natural intelligence. And if I put a human being as an intermediary to secure my network, then at the level of the code, the level of data configuration, at the level of rules adjustment that I'm doing, fine-tuning those tweaks and rules over time, eventually the human being is going to make a mistake, right? That's what happens with these really widely publicized security threats and exploits. So how does this work with blockchains? At heart, what a blockchain allows me to do is distribute the attack vector. That is, that very much like a distributed database, I don't keep a lot of data in just one single place, or even a collection of database nodes that are secured with a single entity or area of control or governance control. What I do instead is that I distribute the data along with the rules that govern that data among a large number of people. And so from a blockchain perspective, what we think of is that the control of that data and the addition of future data as transactions in a distributed ledger are distributed. So that's really the foundation of it. This is what allows a blockchain to be highly resilient, perhaps more so than any other data structure that we've ever seen in history.
So let me see if I understand. So when you say distribute the attack vector, you mean basically break things up so there are more areas, there are more things that as a as an attacker, there are more targets I have to worry about?
Exactly. When I have one giant database to hack, it's this huge tempting honeypot. Mm-hmm. Now, when I distribute the areas that I'm storing my data and the access points, that makes the honeypot less attractive. That's one. Mm-hmm. But let me pass it back to the cybersecurity experts. I'm sure that's happening today, independent of blockchains. Before we continue there,
I suppose it is. Our focus has changed to that of being both business and information centric. So we have to try and enable that distribution of data across multiple systems, but it becomes difficult to do and control. I mean, information centric security as a pure concept really falls back to something that you said a little earlier, Faisal, about it carrying the policy for that data with it. It's a nirvana. It's somewhere that we'd like to go, and maybe block that it can help us do that. But today it's a difficult problem, and we have to use concepts like data arrest encryption, format preserving encryption, tokenization, etc., to hide, mask, and control individual elements of data as they flow through that distributed world, which does mean that the keys or the control point for that is in a different place. But we tend not to have as wide a distribution as I think you're talking about.
And I think these were the starting points. These were the aspirational direction that public blockchains set out to cover or to explore, starting with the Satoshi Nakamoto paper from nearly 9-10 years ago. What it was really doing was building on this notion of distributed databases, which, Jerry, goes back to the idea of reducing or distributing the attack vector, but it's more than that. when we try to lock up things and say, okay, I'm going to use all kinds of crypto and signing and keys to keep people out, then ultimately, if it's in a single place or secured by a single set of identity credentials, then that is a single point of exploit. This happens today if we think of digital identity that is issued by a single authority, like Facebook or Google or the Social Security Administration. These all indicate that I have an issuer of identity, which means that Faisal can only say he's Faisal or prove it if the government office says so, or if Google gives me the sign-in authority to act as myself. For somebody to exploit or imitate who I am, it's as simple as going to this single place and taking over that identity. There are solutions, but I want to pause here.
Yeah, so I think probably an area for Martin to jump in and bring some identity expertise to.
Yeah, I think there's a real tension between the kind of distributed and centralization of identity, and the centralization often reflects the organization that actually wants to often be a traditional or government institution, believes a big database with a big protective wall is the way to go. But actually, in the world we're in now, there's an explosion of connected devices, from mobile phones to embedded devices in your home, thermostats, the number of IoT devices, sensors on manufacturing and factory floors, in the infrastructure of transport. And all those devices are just increasing the volume and data and the level of interactions. So identity is moving to a kind of new level where it's more about the relationships between all those independent entities that may be people, they may be machines, and they're interacting with each other in complex ways. So it may be you setting the position of your seat in the car, your mobile phone talking to the car's entertainment system, your payment application on your mobile phone integrating with the services within a gas station to give your car fuel and recharge it. So that there's a much more complex web and interaction there, and that requires you to move away from having a purely centralized model to decentralizing identity to support those decentralized relationships. And it's also going to create an explosion of data, and data that's of great value about all those interactions that will in some cases be monetized or reflect personal data and need protection as on a privacy basis. So I think that kind of bounces back to being, how do we protect decentralized data with things like blockchain, and how do we put out the intelligence in there to do that in a way that's actually convenient for us to use?
You know, Martin, that's a really interesting point. I want to ask you a follow-up question. You know, with the cybersecurity expertise that you have, I'm wondering about, with the increase in complexity and the connectivity and just the more stuff that's out there, do you see social behaviors or norms starting to emerge for dealing with this? And let me give you a quick example. I mean, you know, it's not a huge network, right? It's my watch is connected to my phone, is connected to my car. I get in my car and, you know, I leave my phone in the trunk just, you know, by accident. My dad calls. I get the call on my watch because my phone forwards it to my watch, and I tell my dad, okay, hold on, you know, and then transfer the call to the car, and then I'm talking, right? And that's a really simple example, but there's all kinds of network vulnerabilities, I would imagine, you know, in that, even that small loop. And I'm wondering what kind of behaviors are emerging. How are people dealing with that?
So there's challenges there in terms of the technology not necessarily supporting the complex use cases we have. So things like you get into a hire car, and the hire car may offer you the opportunity to sync with your mobile phone, so you can make phone calls while you're traveling. But also people have sucked out maybe your contact list. Mm-hmm. So the next user of that hire car will have your contacts list already downloaded into the hire car. So there's lots of ways that data can leak between those systems if we don't put models in place for managing and protecting your data. And some of that, I think, is about intelligence that's in the back end. So you're looking at monitoring the flow of the traffic at huge scale. So it needs machines to help you with that. And some of those algorithms will also be generated to be embedded in the devices. So you create intelligence and evolve those algorithms and embed them in the actual chips that are inside those devices. So those devices need to be smarter about the way they interact with each other and with you as a user, because you need to have that intelligence embedded in them, I think.
Yeah, and I think we also have the issue. If you take the car as the example, actually, where else has that information gone? Because that car's sending telemetry information back to the manufacturer.
Right.
It may be exchanging telemetry information with an insurer in the future.
Yes.
You know, so we have to really consider the complexity of that. Now, I think we're getting to the last 5 minutes, or we're in the last 5 minutes, so we probably need to round things off a little bit. So, Faisal, is there any last comments that you'd like to bring out?
I want to pull a little bit further on the topic of cultural changes as a result of distributed identity, because I believe this changes who we are as a society.
Yeah.
For too long, we've been thinking about central authorities as arbiters of identity. Somebody saying that I am who I say I am because they say so. Now, this is not just a crypto anarchist's dream. This is reality today, and this is being pursued by reputable organizations such as the W3C Foundation, and supported by large corporations, university, and of course government entities as well. Their interest is not so much to relinquish control of identity, but to support the appropriate use. From a perspective of the individual, this gives me the ability to do some very significant changes to the way I deal with the world around me. Examples are that instead of having my identity secured by corporations individually, that is my Google identity and my eBay reputation and say my Facebook stats or friend list or my profile, need not be separate things. They can be self-governed in this distributed identity mechanism. The result of this, it goes beyond just the cyber world. It can go to the way I interact with governments, the way I vote, the way I pay bills, etc.
Yes, that's very cool.
I think one of the key things is entitlement. So rather than you going to an organization and saying, I'm Martin Riley, that's my unique golden identity, it's the fact that I'm over 18 years of age, I'm entitled to this service. It's because I've got a payment mechanism and I can pay for it. It's not the who I am. So sometimes it's carrying those things like entitlement and ability to pay is more important and keeps me anonymous as a consumer or a citizen when accessing services, whether it's medicine, voting, or interacting for payment. Yeah.
So, Jerry, any last remarks that you'd like to bring out?
Well, I'd like to also comment on the societal impacts. Now, keep in mind, I'm not a security expert, but you know, some of the things when I can project out and I see some of the cybersecurity threats that are emerging, especially when you look at the rise of artificially intelligent cyber threats. I see the threat of cynicism arising in our society. So let me give you an example. Once a machine gets better at phishing attacks, and I've actually seen these happen in my own spam filters where things are starting to get through that didn't before. Now I can still tell that they've been generated by a machine, but pretty soon I imagine that I won't be able to. And what that's going to force me to do is just stop returning emails. I'm going to end up being very careful about what I take seriously, what I respond to, what I don't. And I can see that happening in other areas where people just start shutting things off. Wondering though, like I said, I'm not a cybersecurity expert. I'm wondering, if you guys see the danger of that type of cynicism happening with these increase in cybersecurity threats.
Yeah, I think I have to say we do. I mean, if you consider the fact that our staff are both our largest threat and probably our largest asset in really retaining security and cyber resilience within an organization. If cynicism is creeping in, then we'll see our staff effectively avoiding using the secure mechanisms that are there. At the end of the day, if we want to enable we have to bring those staff on board. So really the socio-technical side of cybersecurity is beginning to really take more focus. There's a lot of research going on in that area at the moment. I mean, DXC actually has a staff member who's an active researcher at a university in socio-technical techniques and methods, which he's bringing back into the organization and helping bring that into our ability to do things like risk assessments, considering socio-technical factors, threat assessments, considering socio-technical factors, and the societal change is really quite key in those areas.
Cool.
So I guess we're really getting to the end of our time now. So really, I suppose to sum up, I think a lot of the discussion that we've had has really shown how the distribution of data, the consumption of data, the use of data, identity being one of those key data elements is really driving the need for cyber resilience. As our enterprise environments get more complex, more distributed, we have to ensure that cyber resilience is something that we are really on top of, really driving, and using to protect our enterprise. Reputational damage is one of the key issues that knocks a huge amount off the share price of any corporation. It has been known to drive them into bankruptcy, and regulatory compliance is getting more complex, more difficult, and certainly having more of a financial impact as well. So I'd like to thank Faisal, Jerry, and Martin for their input on today's talk, and thank you all for joining us.
Thank you.
Thank you.
Thank you.
This is fun.